Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. Right, grade 11s today, this is the new topic or subtopic within the same section of qualitative aspects of chemical change, is reaction within which one reactant is in limited supply. Okay, when carrying out a reaction, a chemist, seldom uses the reactants in the exact stoichiometric ratio. Okay, because the goal of the reaction is to produce the largest possible quantity of a useful substance. An excess of one or more of the reactants is often supplied to ensure the most expensive reactant is completely used up. The reactant which is completely used up would be called the limiting reactant. Okay, because its amount determines the amount of the product that is actually formed. So let's take a little of a example first, which I will send in just a moment. Before we look at that example, let's just write down the definition for it. Okay, the definition of a limiting reactant is the reactant which is completely used up. Okay, it's completely used up in the reaction. Okay, it's completely used up. So the example that I've sent in the group from the textbook that I'm using, Physical Science, the Science Tutor, grade 11 by J.M. Lucas. 4 grams of calcium carbonate is added to 250 centimeters cubed of a 0.2 mole per decimeter cube solution of hydrochloric acid. Okay, the following reaction takes place, and the reaction that did take place there, okay, was calcium carbonate in solid form plus 2HCl. This is aqueous. Fix that up. Aqueous solution. Okay, now gives calcium chloride in aqueous solution plus H2O, which is a liquid, plus CO2 gas. Okay, now we got that. Now they say calculate which of the two reactants is the limiting reactant. So we're just going to focus on these two questions there. The second question says calculate the volume of carbon dioxide produced at STP. Okay, now we've been doing a lot of that in the past couple of weeks, so we're just going to focus on A, because A obviously deals with the limiting reactant question. Okay, so first things first, they ask calculate which of the two reactants. So we only have two reactants, HCl, and we also have hydrochloric acid. So the first thing that we need to do is calculate the molar mass of the calcium chloride. Okay, so that should be about 40 plus 12 plus 3 times 16, and believe it or not, that equates to 100 grams per mole. Okay, then we calculate the number of moles of it. So the number of moles we have here is mass divided by molar mass. Let's just scroll down a little bit. Okay, mass divided by molar mass. So we have 4 grams divided by 100, and therefore the number of moles is equal to 0.04 mole. Okay, 0.4 mole or 0.04 moles of calcium carbonate is added to the solution. Okay, now with HCl, which I'm going to do in a different color, okay, we know that the concentration of HCl they gave us was equal to 0.2 mole per decimeters cubed. Okay, now what we do with this, and they also said 250 cubic centimeters, so the volume is equal to 250 cubic centimeters, which is equal to 0.25 decimeters. Okay, now that we got that, the number of moles now, using the concentration formula, we know C is equal to N over V. So we know N is equal to C times V. So we have 0,2 multiplied by 0,25. And therefore, the number of moles that we get in this case is 0,05. So we have two values. Here and here. But from the equation, we know that for 1 mole of calcium carbonate, we need 2 moles of HCl, because there's an invisible 1 here. In fact, let's just write it in here for explanation purposes. So we clearly see that 1 mole of calcium carbonate needs to react with 2 moles of HCl, or we need 2 moles of HCl to react with 1 mole of calcium carbonate. So in other words, therefore, 0,4 moles, 0,04 moles actually, of calcium carbonate will actually need 0,08 moles of HCl. Okay, let me say that again. For every 1 mole of calcium carbonate, we need 2 moles of HCl. So in other words, for every 1 of calcium carbonate, we need twice the amount of HCl. So in other words, here we found the number of moles of HCl to be 0,04. And it's in the mole ratio of 1. And we found the amount of hydrochloric acid to be 0,05, but we actually need double this. So what actually needs to happen is for 0,04 moles of calcium carbonate, we actually need 0,08 moles of HCl. And since they are only 0,05, therefore we can conclude that HCl is the limiting reactant. And that is my presentation for this week grade 11s. This is exercise I just did with you guys on the live class, so we'll ignore that for now. Then we'll have a look at that exercise again next week. That question again, but thank you so much for joining me for the content part. I know it was a very short one, and I'll see you all next week. Thank you so much. We'll open up with that question for our lesson next week. Thank you.